Hello again. In the previous tutorial, we've highlighted how to use normal macros. At this video, I'd like to go further and talk about an advanced variant of macro called XMacro. The main concept of an XMacro is the ability to implement nested macros, where a macro can be defined within another macro. And this is an extremely powerful property. And this makes XMacros very useful for dynamic code expansion. In other words, if you need to rewrite code for multiple items in your program that has similar lines of code, you don't have to manually type that repeated code. Instead, XMacro can do that for you automatically with very little XMacro code. And that's what I'm going to demonstrate at this tutorial, with of course some coding style rules for using XMacros. Let's take an example to demonstrate this. I'd like to begin with writing the code of interest without using XMacros first. Then we will implement the same code using XMacro to demonstrate how useful XMacro is in saving efforts and in fact increasing reliability. However, it generally makes the code less readable, as we're going to see in a moment. Okay, let's begin with the normal code. That's without using XMacro. And for that, the example I'd like to use is building a database for variables, where each variable needs to get allocated a unique ID, a set and get function, and also need to be stored locally, privately into the library. That's a very simple example to demonstrate. And for that, I'd like to create a new header and C files for this database library. Okay, so let's head into our project. First, I need to create a new directory for database to store all the associated files for database in a separate directory, just to make it very easy for me to navigate later on. And it's generally a good practice to do that. So right-click on the main directory, click on New, and select New Folder. And I'm going to call this database. And on this directory, I'll create a new header file. I'll call it database.h. And similarly, we need to create another file, a source file this time, with the same name. Okay, now I want to begin implementing the basic functionality of this library. Basically, to give a variable a unique ID, and then set and get functions, and also to store the variable privately, like a private variables definition. Okay, so let's begin by doing that. The simplest way to define an ID for each variable is to create an enum. For that, I'm going to create an enum, like a type def enum. And I'm going to allocate my variables there. Well, let's say the first variable I want to add to my database is related to the motor I'm using, like a speed of a motor. So let's do that like this. I'm going to give it a prefix for my ID, so database ID, and this variable related to PLDC motor, and it's the speed. Okay, I'm going to set this to 0 as the very first ID. And then this enum, I want to give it a name for my type def enum. I'm going to call it variables ID, or basically database ID. Okay, that's a very simple enum, and that will hold and will allocate an ID for each newly added variable. So if I try to add another variable to the database, let's say I want to add like a status of the motor, then simply this one will be incremented, the ID will be incremented to 1 for the second variable. And that's a very simple way to allocate an ID for each variable. Okay, now let's create a set and get function for these two variables. And that's really simple. So let's set the speed first. So set BLDC speed for the very first variable, and I want that to be unsigned 16. So I give the variable a type, and it's simply BLDC speed. Now let's do the get function for the motor speed. And this takes no parameter, only returns a parameter. Now let's do the same thing for the BLDC status, which is a Boolean variable. For that I need to include the Boolean library. And in fact I also need to include the standard integer library to be able to use unsigned 16. Okay. BLDC status, and the variable type is Boolean, and I'm just going to say BLDC status. Or I could have said just status. Now same thing there, I could just call this speed. Because function parameters are generally like very generic names, you don't specify what sort of speed that is. Okay, now let's do the get function for BLDC status. And that's simply something like this without a parameter, and it returns a Boolean. And these are the function prototypes. Now let's head to the source file and do the function definitions and also variable declarations, variable definitions basically. Okay, so the first thing we need to do here on the source file is simply to include the database header file. Okay, now of course, if I want to be able to build this and compile, I need to include this path as part of the compiler paths. So let me do that now before I proceed. So for that, go to the project properties, and you can navigate there by just clicking this and then Alt-Enter, or simply right-click and click on properties. Now let's hit the C++ General, go to paths and symbols, and let's add a new path here. And that's going to be on top of the project directory path, and it's the database directory. Okay, that's it. And click OK. Brilliant. Now let's define our private variables. So I've added two variables, BLDC speed and BLDC status. The first one is an unsigned 16, and second one is a Boolean. So let's just do that like static variable definitions. And it's as simple as writing static unsigned integer 16 for our BLDC speed, and that's a global variable within the source file, so I need to begin with the prefix g and then BLDC speed. Okay, and I need to initialize this to 0. You need to initialize all of your variables. Okay, same thing, the second variable is our Boolean status, so that's a BLDC status, and I need to initialize it to false. Okay, there we go. And generally speaking, you need to align the function definitions. If you do them, align on the same lines. Okay, now the second thing we need to do is to do our function definitions. So let's copy all our functions from the header file and then define what those functions do internally, which is very basic and very trivial. Okay, so simply what they're going to do is that they're going to copy the value from the passed parameter to our internal library private variables, and that's BLDC speed. So we want to set the speed to whatever user pass through this function, and that's about the only way you can update the variable speed, by just calling this method. You can't manually, you can't just directly access this variable because it's static within this database. And that's basically the idea of this database example. Now let's do the get BLDC speed, which is simply returning the private BLDC speed within the library. Similarly for set and get status. To set the status, we want to assign this user passed status to our database variable version, and then to get the status we simply just return the status variable value only. Okay, and that's basically the code that I wanted to demonstrate. And now you can just go add this library to the main and you can experiment with this library. Let's do a little bit of experimentation. So that's database.hitch, and I can simply set the BLDC speed here, like initialize the value. I can set it to like 1, 2, 3. Similarly, I can set the status. Let's say that I'm going to set it to true. And now let's do a quick basic demonstration where I print the value of the speed and the status. So let's do that. And then status. Alright, now let's pass the parameters, and those are simply, we're going to call the get speed function and the get status function for the motor status parameter. And we're going to check if this one is equal to true, then we're going to write true as a text, otherwise we're going to write false. Something like that. So let's try to build the project and see if we have got any errors or warnings. Okay, excellent. No errors, no warning. Now let's navigate to the project directory and run the executable file. Okay, excellent. So motor speed is 123 RPM and the status is true in text. So excellent. This one is working, and this is the version of the code without using XMacros. Now let's have a look. If we try to add another variable to the database, let's see how many steps this one involves. So if I try to add another variable, let's say motor direction, I first need to add a new ID there. So that'll be BLDC motor direction. I need to add an ID for it. And by simply just inserting a new element to the enum, it will get allocated a new ID number. Okay, so that's the first step. The second one, I need to create a pair of, I need to do function prototypes for its set and get functions, which involves, reasonably lots of writing actually. So let's write that. So set BLDC direction. And then the direction is basically, could be just true and false, so a boolean. And the get function. And this function takes no parameter and only returns the BLDC direction. And then on the source file, we also need to add a new variable into the database for that. So static boolean BLDC direction. And we're going to initialize this to like false, and assuming false is equal to clockwise, and true is counterclockwise, things like that. Okay. And also I need to align the variable initialization assignments values, operator equal sign. Okay, now let's do the function definition. I think that's the last step involved with adding a new variable to our database. The one, of course, without using XMacro. Okay, to set the direction value, it's very simple. We simply need to set the static variable to whatever one passed by user, by value. And to get the BLDC direction, we need to return the direction variable. And that's simply how to add a new variable. It involves lots of steps. So we need to add the ID, we need to create a new function prototype for set and get, and we need to define the set and get functions, which are all trivial steps basically. They're all identical to whatever we did to the other variables, except the type is different. Okay, so that's how to implement this code using normal method without using the XMacro privilege. Alright, now let's have a look at how we can do the same thing using XMacro this time. Well, the first thing you need to do with XMacro is to define something called the list macro. Well, in fact, I don't think it's formally called a list macro, to be honest, but I personally like to refer to it as the list macro. And that's about the only place that you interact with the whole XMacro thing. That's where you add a new element, delete an element, and you need to pass as much information as possible about the element to be able to automate the other parts of coding. And we're going to see all of that. So first, I'm going to replace all these instances with their equivalent XMacro. The first thing, as I said, is to create the list macro. Okay, now I'm going to begin by typing that. It might look counterintuitive, but as soon as we see the whole picture, I think it will start to make sense. So I'm going to call this database list, and I'm going to create the first element, and that's my BLDC speed. And I'm going to pass as much information about it that I need to create the other parts. And that's the set and get function prototypes, the variable thing, and also the function definitions. So I'm going to call the individual elements within the list as the data. So this is database data, and I'm going to pass 3 parameters to that macro. So the first one is the ID, so that's going to be my BLDC speed ID thing, like the enum element, and I'm going to define this as a whole here. And the second one is the type of variable, and I want that to be unsigned 16. And the third one is the variable name within my library, so that's going to be G BLDC speed. But I can just pass BLDC speed, and I can add the G prefix later on. Okay, and that's the first element. Okay, and I think we're done with this one. I'm not going to add these other 2 elements now, I'm going to add them later, but let's see how we can deal with a single element first. Okay, now the second thing is that we need to do our enum in a pretty much the same way, but now we are going to use XMacro to do that. So in order to do this whole thing using XMacro, we're going to delete the elements that we done manually and only allow the macro to allocate those automatically. Okay, so for that we first need to define the data macro here. So we have passed elements to the data macro, but we haven't defined it. So let's define it here once for our enum, and this macro gets 3 parameters, and those are the row ID, the type, and the name, in the same order as we passed those information in the first place. Okay, and we need to now define our enum list. Basically, on our enum list, we don't want to take anything else apart from the row ID. So we're simply going to use the row ID as an element of our enum and put the comma. And now we can just undefine this macro because we used what we need, and now just undefine it locally. And that's simply it. Now if you'd highlight on the well, first actually I missed one step, and that's to call in the database list as a nested one within this macro. And that's the one that's going to allow this automation process to take place. Because now if you just highlight the database list, it is a database ID BLDC speed. So this enum is going to have this element here. So this is simply how to create a dynamically kind of expanded enum, because now, guess what? If I try to add the second element to the list, it will automatically get allocated an enum as well. So let's do that in fact. So let's do the second element, which was a BLDC status, and the type is Boolean, and I'm going to call it BLDC status, and I'm going to add the G later when I get in there, but that's just the generic name. There we go. Now let's have a look at our enum list. Sure enough, so we've got BLDC speed ID and also BLDC status ID that we passed here. It literally got copied right here by just typing this code. This is equivalent to listing the enum variables as we did early on and separate them with commas, just like this. Isn't that cool? Okay, now let's do the next one, and that's to handle the function prototypes. The previous one, without using XMacro, we had to manually type all those, but with XMacro, we don't have to type them manually. We can format that dynamically. And let me show you how you can do that. So, the similar thing to what we did here, we need to define our macro, and when we're done, we need to undefine it. And then somewhere in the middle, we need to call in the database list that the user is going to use to pass those parameters. That's the same for every XMacro. This is kind of the format, and that's the syntax and how to use an XMacro. And basically what this does is just going to use the data macro with all the parameters passed, but the parameters are coming from this database list. And that's why it's kind of a nested macro, where series of macros uses another ones within inside of them. And we utilize this by creating dynamically expanding code. All right, now for the function prototypes, we use the macro to define the functions. So on here, I'm going to begin with the function, with the set function, and that's always going to return void, so it returns nothing, and it's called a set function. But the only thing changes is the name of the variable that we are passing here, PLDC speed or PLDC status. So we're going to use the name that the user passed to name this function, and we simply can concatenate this name with the set that we're written with these double dashes. And now this is going to be equivalent to, for the PLDC speed, it will be equivalent to just the text set PLDC speed. So whatever name we pass, its text is going to be replaced by this operator here. It's a very simple thing. And now the set function takes on a parameter, which is, it takes on the type unsigned 16. So literally we need to write unsigned 16 and then the name of the variable. So we can just do that, unsigned 16, which is the type that we pass to the macro. So this is the type field, and then the name of that variable. This is the same thing as, so whatever we type here, if we return unsigned 16, is going to be replaced here instead of the type, and same thing for the name. And this is going to result in something like that. And that's lovely, that's what we want. Now, terminate this function prototype with a semicolon, and let's jump into the next line. And now, let's do the get function. Now, the get function returns the type, whatever type user select. So we're going to return the type, and this is called get. Same idea, we're going to concatenate the name of the variable to the function name. And this one takes no parameter, so that's a void parameter. And as simple as that. Now, if I'm going to take a look at the database list, to my surprise, I can already see my correct function prototypes for setting PLDC speed and get PLDC speed all in exactly the correct format I expect, and also setting get PLDC status. Isn't that amazing? With just these little lines of code, we can dynamically expand our code. Now, I don't really need to write any of those. I can just delete them because the XMacro done that for us. And now let's have a look at the magic inside the source file as well, and how we can use XMacro in the source file. So the first thing is to do my private variables. So to do that with the XMacro, I guess you got the idea by now. We need to define the data macro. We need to put the data list and also undefine the macro when we're done working with it. Okay, so let's start working with the macro. So the first thing here is the variable takes on this format. It's a static variable, and we need the type that the user specified. So simply static type, so whatever variable type the user passes. And then we're going to give it a name. So that's going to be a G, and then we're going to concatenate with the variable name. So that this one is going to become G PLDC speed in the case of the PLDC speed name macro parameter. Okay, so that's really simple. And I'm going to go a new line. As simple as that. And now when I have a look at the database list, here we go. I get my unsigned 16 for BLDC speed and static boolean for my BLDC static. Amazing. And now finally, we just need to do the function definitions, which generally tend to be very long lines, but XMacro certainly going to make them a lot shorter. So let me copy the format of the XMacro kind of nested calls, and let me work in there. Oops, sorry. All right. So for my function definitions, it takes on similar format to the function prototype macro, except this time we need to define the body as well. So I think a good starting point is just to copy the function prototype as a whole. It's identical, but with just differences into the definition. Now, instead of just declaring this as a prototype, now we actually need to write some code in there. So I need to get rid of the semicolon, and I need to put some braces. And my code there is simply just the variable. So it's going to be the variable name, and we're going to assign whatever variable the user passed to that function. So that's going to be name. Because now this is a function, so whenever user call this function, we're going to assign the global thing here with the value passed by this function prototype, which is really intuitive. And we need to terminate this code as well, and this slash to go to the new line to continue the macro, because if we delete this slash, the macro will be broken here and it's not going to continue to the next one. So we need to do that here to have multiple line macros. And of course, you can read more about macros formatting thing. It's really simple. To write multiple line macro, you need to use this slash to continue the macro. Otherwise, you'll be forced to write the entire macro in a single line, which is really unreadable, as you would imagine. Okay, so we're done with the set function. That's pretty much it. This is our set function. And if I have a look at this, I can see the code getting expanded by the macro. This is the macro expansion. So the set BLDC speed has already been written for us. Now let's do the get function, which is apparently even simpler. So for this one, this is no more a function prototype. So we need to go to the new line and do add braces for the function. And also need to jump into the new line once we're done. So for that, we're simply going to return the variable. And this is the variable name. Okay, we need to terminate this with a semicolon. That's pretty much it. So this code is equivalent to the whatever code we write there. So let's have a look at the expansion to verify. So now set BLDC speed has been allocated a set function, which does gbldc speed equal to BLDC speed, the local one passed by the function. And the get speed is also just going to return the variable BLDC speed. Same thing for the set BLDC status and also get status. And all based on our XMacro lists. Okay, and in fact, I can just delete those function definitions. I don't need them anymore because the XMacro is doing that favor for us. And now I can also delete these variables. I don't need them anymore. And now let me add the third variable. It's as simple as just coming later to the list. You add a variable, you specify the ID of that variable. I'm going to call it direction. And the type is Boolean. And I'm going to call the variable BLDC direction. And as soon as I save, I'm going to have a look at my enum list. Sure enough, this has been added here. And I can see them in multiple lines if I like to. So here we go, they're in multiple lines. So BLDC speed, status, and direction. And the setting gets functions for all the variables that I've added, including the one I've added recently. So this is, sorry, let's have a look again and expand this. So sure enough, I've got status and direction too. And same thing for the source file. I can see all my variables being defined, and the function definitions, of course. There we go. Now let me just build, just to verify this one works. And again, for my functions, for my get and set functions there, they are using this syntax. So I can just go here and get the function name and call it in my main. So if you don't know how to extract this, let me just delete this just to show you that how we can get that easily. So what you need to do is to go to the macro that does the function prototypes, highlight here, right click on this. You're going to get this expanded list and simply just copy the function you want to use. So I want to get my BLDC speed, just copy it into the main and just call it here. Now same thing for my motor status function. I'm going to head to the macro here. Just click on the list macro name call, expand this and get BLDC status. And let's just call it here. All right, let me build. And those in fact remain the same because we kept the XMacro the same convention. So let's build. Awesome, so no warnings, no errors. This is, of course, I know how to use this. I'm very confident at using XMacros. XMacros generally are very unreadable, as you can already tell. There's no way you can tell this is doing all that work unless you go through these and highlight all of that. But I'm very comfortable with using XMacros, and it's extremely useful. It really shortens. Now, anytime you want to add a variable to the database, you simply just add it to the macro list, and you don't need to do anything else. And the variable is extremely reliable because it's being tested and it's working. There's no way you're going to make a typo that's going to break the link. Well, of course, you need to be very sensible with the macro use. It's a very unreadable thing. But anyway, let's just demonstrate and prove that the XMacro actually works. So let's go to our debug folder and run the executable. And excellent. So our motor speed is 1, 2, 3 and status is equal to true, exactly as we set them early on. So that's it, and this brings me to the end of this tutorial. I hope you can see how useful XMacro is in shortening any expandable code that has so many repeated lines of code that we can just automate using XMacro. Thanks for watching.